We are going to solve a question of planes. The question statement says that there is an equilateral triangular lamina of 25 mm sides that lies with one of its edges on HP such that the surface of the lamina is inclined to HP at 60 degrees and the edge on which it is resting is inclined to VP at 60 degrees. Okay, so let's minimize the question and start solving it. We have to understand that in the questions of planes, in the first stage we have to start with drawing the true shape of the plane. Question is, in which view, the front or the top, should the true shape be drawn? In this question, the statement says that one edge of the plane is on HP. So we can start our drawing by assuming that the entire plane is on HP. That means the true shape will be visible in the top view. Not only that, the orientation of the plane will be something like this, in such a way that one of the edges of the plane is kept perpendicular to VP and towards the left side of our drawing. And we'll see how this will result finally in this edge, which is perpendicular to VP, being kept in HP in the second stage as is required in the question. So let's take up the projectors for now from the edges, and let's also name the edges A, B and C. Okay, so this is A, B, C, and in front view this A and B will appear as coinciding, A dash B dash, and this end will be C dash, sorry, this end will be C dash. Now we can also make this a little more prominent, the front view, to indicate that this is our front view. Okay, now in the second stage always we should select the angle which the entire surface of the lamina is making, and in this case the entire surface of the lamina is making 60 degrees with HP. So let's say this is 60 degrees with HP. Okay, and we have to take um, the front view length that we have obtained in the first stage in our compass and cut an arc on this line of 60 degrees that we are drawing right now. So please take that much distance. How much distance? It will be this distance, okay, which has to be marked here. So let's mark that distance here. So it should come somewhere here, okay, something like this. And now we can name the same points A dash, B dash and C dash here. The only difference will be because we have to differentiate with the points of the first stage. We'll name them A1 dash and B1 dash here, and similarly we can say this is C1 dash over here. Okay, now if you see, this is our second front view, and we can just make it a little darker. We can make it a little darker to show that this is our front view. So this line should appear a little darker as compared to this construction line, and then we can take our projector lines down into the top view from the vertices like this and like this. Fine. Similarly, we can take horizontal projectors from the points in the previous top view like this, and wherever these intersection lines from the top views and front views meet, we have to get our points. So for example, this point A in its horizontal projector has to meet with the vertical projector from A1 dash in the front view, and this point will call as A1 in the top view. Similarly, this point will be B1 and this point will be C1. Fine. Now we can join these points to complete our second top view. Okay, as we can see, we are able to uh, keep one edge of the plane on HP as was required. One plane of HP on as required. Okay, I'm just moving it a bit so that we are able to draw the line. Yeah, fine, I think now it will work. So I was saying that our edge a1 b1 is on HP. If you can see, this a1 b1 is on HP, which was a requirement, and that's why we had put AB edge perpendicular to VP in the first top view. Okay, perpendicular to VP in the first top view. Now let's darken it a bit. Now top view, the second top view. Like this, just so that it looks a little different, a little darker as compared to the construction lines. Fine. Now what we can do is we have to go to the third stage of the question. In the third stage of the question says that this resting edge is inclined to VP at 60 degrees. Okay, so which is the resting edge? We can see that the resting edge is this A1 B1 dash. We can see which edge is resting in the front view. See, in front view we can see that C1 dash is above HP and A1 B1 dash, which is an edge, is in HP. Now this edge on HP is at present perpendicular to VP and it has to be made inclined at 60 degrees to VP. So that's why I am drawing a line inclined at 60 degrees to VP like this. Okay, and we have to redraw this entire grid in such a way such that this edge becomes inclined at 60 degrees to VP. So I'm just taking the grid construction here. It's very useful. Okay, something like this, and then we can go ahead and draw the top view of the triangle. We are just copying this image inclined at the appropriate inclination in the second on the third stage. Okay, something like this. So this is what we are doing here. Okay, now we can name the points as well. Just to indicate that this is the next stage, we'll name this as A2, B2 and C2. For the final front view, we can take up the projectors into the front view from these vertices. Okay, from A, then from, let's say, B, and finally say from C. Okay, and we have to take the projectors from the previous front view as well, and wherever they intersect we'll get our points. And again we have to mark on the projector coming from A2, not here, the projector coming from A2 is here and the horizontal projector from A1 is here. So we'll get our point A2 dash over here like this, and the projector from B2 is here, and this is also an HP, so we can write B2 dash here, and the projector from C2 is coming up here and the projector from C1 is here, so this is our point C2 dash. This completes the location of the points. Now we can join them to complete the projection. So take A2, C2, B2, sorry, just a minute, to select this point C2, B2 and then finally A2. This completes the projection. Okay, that's it. Thank you.